Hello friends, welcome back to the Dr. TRSDOS channel. I'm Dr. TRSDOS, your host. I wanted to make a video about starting TRSDOS on Circle M hardware. So Circle M has two platforms I support. One's an F91, the other's F92. I'm going to be demonstrating the F91, but it's identical procedure for either one. I'm going to use the latest version of TRSDOS, TRS-OS, where I'm developing networking to connect TRSDOS platforms back to a PC so they can store disk data on the hard drive of a PC, which is so much more cost effective and so much more versatile if we can read and write. I plan to also route the printer and some other devices from TRSDOS over the network link one day so that you can print directly on a PC. That's not a real high priority right now. We can always print to a file and transfer that to a PC and print the file if we need it printed. That's not a problem. So I have an icon here for the TRSDOS networking program, and we're going to drop it in here, get it down to a size we can deal with. Now the name of the file here that we're going to use, I have to remind myself, to be honest with you. We're going to use a 720K. So I already have this is the file name located on the PC. So this window here is an application running on my desktop, and in my desktop I have a TRSDOS folder, and it wants to know in that folder there is here, let me show them to you. In that folder is 4 files, and I want to each one of these files is a file system. There's a 720K, a 180K, a 1.2 megabyte, and this one I didn't include in the file name. Its size, it doesn't matter. It's another file that has a file system in it. We're only going to deal with this one right now, SYS 720K. So over here on this screen, by the way, this application was developed in Python, so I hopefully can make it available on a wide range of host platforms. So that's a disk file, so .dsk, sys720k.dsk. We're using the serial port for this network connection, and I'm going to run this at this is pretty much the bare minimum speed, 115,000.2 baud, kbaud. That's if we're doing a lot of disk accessing, that's pretty well going to be. And then I pick that number because I say that because the system it pretty well runs at about the speed of an original floppy on a TRS-80 at this speed. So here we're going to select which COM port we want to use. I just happen to know that it's number 1, COM 9. So now we have a server statistics screen that shows the different commands that it's received from a client such as bind, control commands, echo, pings, gets, puts, reading headers, etc. This system here on the center screen is Circle M's hardware. We're to TRSDOS ready or LSDOS ready. I'm going to type boot, so we go back all the way here. This is, and plus I'm going to press reset on the Circle M hardware here now. Okay, so you can see it scrolled up. This is the normal CPM startup screen on the Circle M hardware. We need to switch to drive C. And then there's a program here called OSLOAD.com. And there's a file called TRS-OS.bin. So all we have to type here is OSLOAD space tris-os, and you don't need to put the .bin. It'll default to that. So OSLOAD tris.os. It pinged the server. If you noticed on our left screen, ping now equals 1. It's received control commands, pings. I'm going to hit N here on the center screen for our network utilities and tests. And at this point, there is no volume. Everything is empty because even though we pinged and we know a server's out there, we don't know what that volume, what size it is, and its parameters, how many cylinders, sectors, etc. that we're dealing with, how much space is available. So for fun, I can hit P again and ping the server. We already knew it was there. If you'll notice, the ping on the left went up again and incremented. Press enter to continue. I can echo a packet. This is for diagnostic purposes. It sent a test packet, received that packet back and compared it, and if they match, it's going to report, or if they don't match, it should always match, of course. Now at this point, I'll query the server, and it has now, it tells us the server replied. I'll press enter to continue, and now if you look at the top, it has a volume name, the date it was created, the total space on that volume, and some other parameters down through here, such as the cylinders, maximum cylinders, etc. You get the drive code table you can find in your LS-DOS, TRS-DOS technical reference manual that was published by MySosis, by Roy Soltoff, the author of all this operating system, or at least the architect of it. And that manual can be downloaded at Tim Mann's website. It's Tim, T-I-M-M-A-N-N, is his last name. If you Google his name and TRS-80, you'll find his website, and there's a download section, and he has all the technical manuals and software that you could ask for. So I'm going to press escape. Did I bind? Now I need to bind. I don't know if I did that. I'm going to hit B here, and we're going to bind. And that now binds our network volume, which is 6. Number 6 is used for the network here in TRS-OS. It's now bound to what we just queried on the server. Okay, I'll press escape, go back to the main menu. If we look now, we have volume 0, or root volume. It's a 360 kilobyte volume. Data disk and drive 1 is, and drive 0 is read only. It's binaries, programs, and if data goes unchanged, and so it's write protected and it's a protected core of the system. I like to look at it as drive 1. It's only 51 kilobytes, and this is a small read-write drive where we can volume where we can have startup JCL files, etc. run, because we need space we can read and write when we're starting up to create temporary files while it's running job control language, etc. Volume 6, that's the network volume we just bound to this system. Says it's a 737 536 bytes. Now I'm going to press 0. If you notice, 0 is starts TRSDOS normally using default terminal 4. I can tell you that the terminal type of 4, is VT100. Starting background, multitasking, all of that checked okay. The clocks were running. It started a session, created a session terminal, and connected us to TRSDOS. That's important to note that TRSDOS was there and ready to run. There was a session terminal created. I used VT100, which was set option 4. There's other options such as adds 25, teletype. It seems like I'm missing something, but so now we're at a TRSDOS ready. Here, I use TRSDOS and LSDOS interchangeably. If we look at drive 6, if you notice on our left, our server is responding. Right now, it's updating that screen on every sector it reads. I'll be changing that because of performance reasons, so that we don't report it on every single read. So it was about the same speed as a floppy on an original system. Here you can see the directory of that system. Once it's in memory, once it does read it across the connection and it's in memory, we're running at 50 megahertz, screaming here, so it sure makes up for it. It scrolls that directory. When you hit a key to go to the next, on an original Model 4 where it sorts the file names and everything, there's a pause of several seconds. So, on these F91s and even the F92, it's like lightning. On the right screen, I have an emulator running. Give a shout out here to the TRS-80 GP that I use a lot of times. I only use it for one thing, the Model 4, but it sure emulates a lot of TRS-80 models. It's really been a godsend to be able to access that and use it, and it really works wonderfully. I really want to give them credit. It probably works better than any emulator I've ever used professionally or at the hobby level, either one. But I want to show you that drive 1 here, I'm using the same file, SYS 720K disk. For drive 1, I'm using the exact same file that I'm using over here on the network side. And so they're sharing this one file. It's wonderful that it works out that way. But that certainly saves me a lot of time. I have one problem here on the emulator when I do go to access. There's quite a long pause. It takes it a little while to read it, longer than normal. I'm not sure exactly what's going on with that. Hopefully, that can be fixed and get it. But once it reads it, it's up to normal. So we're going to do that here. Let's go ahead and type dir directory 1 on drive 1. And you see we got a several second pause here. And the cursor kind of stops blinking and everything. But ultimately, it will read the directory, as you can see. And you compare that to the one in the center, and you'll find that they're the same drives, reading the same volume, sharing that volume. So that really comes in handy for me to be able to transfer files around here on the system, from the new system to the old system and vice versa. I wanted to show you how to start up the Circle M hardware using his OSLOAD and loading TRS-OS. And for those of you that have Circle M hardware and you want to load TRS-OS and get started. Now, if you don't have the network server Python program, don't worry. When you start up TRS-OS, it's simply the ping's going to say nothing is there. It may pause a few seconds while it's pinging, looking for a server, but there's none there. It's still going to start up anyway. That's no problem. And I'll be posting the newer server host program here soon, so everyone will be able to share that. I hope maybe this shows you how to start that up. We need to also have a video on the Agon, and then the Zilog development boards. Well, I hope if you have one of those that you already have a good idea of what you're doing, but I certainly can do a video on starting up the development systems also. And I hope some of you out there have the Zilog development system for hardware. We certainly need some people doing some projects here and development work. Thanks for watching. Many thanks. And I hope to see you back here again soon on the TRSDOS channel.